You're testing the claim that the proportion of men who own cats is significantly different than the proportion of women who own cats. You sample 60 men, 70% own cats. You sample 200 women, 80% own cats. Find the test statistic rounded to 2 decimal places. So let's write our formula down. The z-score for the difference, so it's p hat 1 minus p hat 2 divided by the standard deviation, which is going to be the square root of p bar q bar over n1 plus p bar q bar over n2. So we know p hat 1, that's going to be, we'll just use the first one, so that's 70%. And we know p hat 2, that's going to be the women, so that's going to be 80%. So now we just need the weighted average for p bar and q bar. So p bar, that's going to be 0.7 times the 60 plus 0.8 times 200 divided by the combined sample of 60 plus 200. So this is going to be 70% of 60, what is that, 42, plus 80% of 200, is that 160? And then divided by 260. So what do I have? I have 202 divided by 260. So this gives me a p bar of 202 divided by 260 is 0.777. So 0.777. All right, so that's p bar, right? So q bar, slide that up a little bit. We know q bar is just going to be 1 minus the 0.777, so I don't think we need a calculator for that. What is that going to be, 0.223? All right, so now we can just fill everything into the formula. So what do I have? My z-score is going to be 0.7 minus 0.8 divided by the square root of p bar q bar, so that's going to be 0.777 times 0.223 divided by n1, which was 60, plus the same thing, 0.777 times 0.223 divided by n2, which is 200. All right, so now we're just going to crunch that in the calculator. So slide that up again so we can see everything. So we know that the numerator is obviously negative 0.1 divided by, and let's go the square root of 0.777 times 0.223 divided by 60 plus 0.777 times 0.223 divided by 200. And we get 0.06. So this is 0.061. So now we just divide that out. So we're going to go negative 0.1 divided by that previous answer. And I get negative 1.63.